Hello everyone. I'm sure some of you might have seen my activities for classes 6 to 10 which I have posted earlier. I'm starting with the MATLAB activities for class 11. This is the first MATLAB activity. The objective of the activity is to find the number of subsets of a given set and verify that if a set has n number of elements, then the total number of subsets is 2 raised to the power of n. A very simple activity. Let us start doing it. The material required is not much. What you need is a paper, different colored pencils, and your geometry box. So let us see how do we go about it. I take 4 sets. Take the first set as the empty set. I call it A0 and obviously it has no element. I take my second set which is A1 and I take one element in it and I name it, let's say, A1. Okay. Now the next thing is I take another set A2 and A2 has two elements, say A1 and A2. A3 is the fourth set that I'm taking and it has three elements, say A1, A2 and A3. Now let me try to represent these sets. I take my first set A0 and A0 is what? It's an empty set. So I represent it just with a circle. There is no element you can see in it. And this is figure 1.1. You all know that how many subsets are there for an empty set? An empty set has only one subset, which is the set itself. An empty set has only one set. An empty set has only one subset, which is A0 itself, the empty set, represented symbolically by these two curly brackets without an element. There's another way to represent this empty set. I can represent it like this also, but I've used this notation, two curly brackets without any element in it. So the number of subsets here is going to be how much? It is 1, and 1 I can say it as 2 raised to the power of 0, right? Let us go to our second set, which is A1. A1 has how many? A1 has only one element. So I represent this A1 like this here. The set A1, this is the set A1 represented, and I have this element A1 written here. So this is the inner portion, and I have this complete set as A1 having one element as all A1 here. So this particular is figure 2. Now, how many subsets will this set have? This set is going to have the two subsets. Number 1, the empty set, and the set itself. This is having only one element. So there are two subsets to it. So I have an empty set and the set containing the element A1. So the number of subsets of A1 here is 2, 1, and 2, and 2 can be written as 2 raised to the power of 1. So when I'm having the set A1 having one element, I'm getting the number of subsets as 2 raised to the power of 1. Let's represent our third set A2. A2 is having how many elements? A2 is having two elements, A1 and A2. This was the empty set. This complete was representing A1. And the outermost shell, this complete, this whole thing is being representing what? It is representing A3, having two elements, A1 and A2. Now, if you can think it of, how many subsets will it have? It is going to have the subsets as the empty set. A1, I'll take all the single elements, A1, A2, and a combination A1 and A2. So it is having how many subsets? Having 1, 2, 3, 4 subsets. So 4 subsets means that when I'm having two elements, A2 is having two elements, the number of subsets is how much? It is 4, and 4 can be written as 2 square. So I think you can identify if there are two. We had in the previous slide I had shown you, when there was one element, the number of subsets was 2 raised to the power of 1. When I'm having two elements, the number of subsets has come out to be 2 square. Let us go on to the A3. A3 is having how many elements? It is having 3 elements, A1, A2, and A3. This was the empty set. This was the set A1, which was having one element. This was the set A2, which was having A1 and A2 as the two elements. Now this is set 3, A3 set. A3 set is having 3 elements, A1, A2, and A3. Anybody who can think of that how many subsets are going to be in A3? See, let us try to count the number of subsets. I can take as the empty set. Then I can take the single elements A1 as one subset, the set containing the element A2, the set containing the element A3. Then I can take A1 and A2, I can take A2 and A3, I can take A1 and A3, and finally I can take A1, A2, and A3 together. So how many subsets do I have? I have 1, 2, 3, 4, 5, 6, 7, and 8. Can you identify the pattern that is there? When I had 0 elements, the number of subsets was 2 raised to the power of 0, that was 1. When I had 1 element, the number of subsets was 2 raised to the power of 1, that is 2. When I had 2 elements, the number of subsets was 2 raised to the power of 2, which is equal to 4. When I had 3 elements, the number of subsets are how many? They are 8. And 8 is what? 8 is 2 cube. If I continue this way, the number of subsets of an containing n element a1, a2, a3, an is going to be 2 raised to the power of n. Let us just jot down our observations. The number of subsets a0 is 1, and 1 is what? It is 2 raised to the power of 0. The number of subsets of a2 was 2, and that is equal to 2 raised to the power of 1. The number of subsets of a2, which had 2 elements, is 4, which is 2 square. The number of subsets of a3, which had 3 elements, is 8, which is 2 cube. So same way, if you go ahead, the number of subsets of a10 is going to become how much? I'm sure you might have guessed it right. It is 2 raised to the power of 10, which is having 10 elements. And same way, the number of subsets of an having n elements is going to be 2 raised to the power of n. So this is what we have observed. The activity can be used for calculating the number of subsets of a given set. I hope you all have understood. If in case any doubt, you can watch the video again. Thank you so much.